All right, welcome to the Utah Kubernetes meetup. It's good to have you here. The speaker today is me, so I apologize. But I usually do these type of things when I really want to learn something more, because that's how you learn, is getting ready to present or teach. And also, it crept up on me a little bit October, because we had just had an internal developer conference, which was great. And what happened in that internal conference, I was helping organize that we had lightning talks, which I really like. And I gave one, Carson gave one, several others. But 10 minutes is not a lot for some subjects like this. And so I thought, okay, I need to learn some more. So that's why we're here. That's what I'm doing tonight. And let me get some slides going here for us. Let's see. Exception for a minute. All right. So this is the title of the presentation. And I think actually it may be that I'll present on some of the stuff that's in here. We are going to talk about ephemeral containers. But to get there, I just want to do a quick review. Last couple of meetups and times we've had people that aren't the expertise, didn't have the expertise as me, either online or here in the audience. And so I'm just going to do a very quick review. We're going to have a little quiz. But those that have been around a while and you know who they are can't answer them unless nobody answers them. Okay, but we'll get to that in just a second. So first of all, Kubernetes cluster. How many different diagrams has one seen about this? There are tons of them. First of all, I try to give attribution of where I get these things from, because I can draw this thing. And the most important thing that I will say of this talk would be the references at the end. But the reason I bring this up is I just want to make sure that we're all on the same page as we develop more into this topic of ephemeral containers. Again, Kubernetes, wonderful orchestration system. The ecosystem has a control plane and actually executors, if you will, those that actually have the applications on it. You have the control plane that has schedulers. You have etcd or some key value to store to keep the jewels of the cluster. You have an API server which interacts with the cluster and the control plane. You have control managers. You have the job controller. You have the token secret controller. You have a node controller. You have controller. There are lots of controllers. And then this one here that's off here is really the cloud controller, which you're not going to see unless you are hosted in a cloud environment. And that is a controller that manages the interaction with the cloud. Okay, easy. Okay, next. Okay, what's wrong with this diagram right here? What's wrong with this? Think about version 1.20. Oh, there you go. Okay, so 1.20, they deprecated this as a container runtime. Now, there's various reasons why. But what's interesting, just as trivia, is Docker really a runtime engine? It actually invokes. It's kind of a shim in front of. And what's interesting is that Google and the Kubernetes folks used another little kind of shim to go onto the shim to do the runtime. And so what they decided to do is eliminate that. Standards OCR, Open Container Initiative, various different, the run C, container D, a bunch of them. And so that is incorrect. But what I'm bringing up here is there's a container runtime piece on a node, physical, on a node, a compute system. You have pods that make up your applications. You have pods that may just have containers in them. You may have pods that have containers and then mount file systems or it's pretty easy. Okay, quiz number 1. What is the difference between a pod and a deployment resource in Kubernetes?
It's not allowed.
Well, that's true. Either online or someone in the room. What's the difference? All right, anybody can answer.
One starts with a P. And the other starts with
Okay, another person answer it.
A pod is the things that run, and the deployment is a description of the thing that runs the thing that runs.
That's probably the most definitive answer I've never heard.
That's accurate, while also
And I
explaining
still haven't heard
Really useless.
So,
explanation.
yes and yes and yes and kind of, but let's.
I mean, you could have a deployment with 1 to n pods.
Okay. Is a deployment an actual
Runtime?
it's a runtime? Okay. Don't date me. Okay. Kubernetes, early days. Even I remember when it was first released, or actually before it was released, we didn't have deployments. What did we have? You remember?
We still have it.
It wasn't even replication.
Still have them.
Replication controller.
They were replication controllers. They weren't replication sets. That came later. But the point is here, I want to make the distinction is oftentimes we just, oh, it's deployment. Because really the deployment is to facilitate managing, orchestrating the conditions by which the pods will run, like replica sets they can allocate to, and other things that are part of the deployment. The reason why I bring this up is when we talk about ephemeral containers, I'm not going to talk about deployments, but I'm going to deploy deployment to get to pods. I'm bring it up. All right. So here is representation of a deployment. Okay. Again, these replica sets is kind of a history of deployments of pods. Okay. And these are the ones that also then are those that get expanded as you get more replicas, if you will, in this phase. Okay, so that's this deployment site. Okay. Very well done. Quiz number 1. Quiz 2. What is a pod's startup sequence?
You got your pre-start hook,
Okay, pre-start hook.
and you're not counting scheduling? Once the pod is
Outside of the control plane,
okay,
the control plane has said, I think I want to have a pod here.
it's scheduled on a node.
Scheduled on the node, so several things got involved in scheduling it.
Right.
Okay. And what first happens?
You have
CNI.
you.
What?
No, good call. CNI.
Yes.
CNI?
It's invoked in the pod.
Okay, yes.
You probably have the setup of all your volume, so getting data for secrets and config maps,
Sure.
environment variables,
Yep.
or especially volume mounts, it has to happen really early.
Okay.
Init containers.
And init containers, exactly. We're going to get to that. But Greg can answer this. Do we still have a pause process? You know what a pause process is?
Pause container.
Yeah, the pause container.
Oh,
What is a pause container?
that's there to hold on the network namespace for the pod.
And networking and other things. They actually, it used to be a lot more, but it's been relegated lately to be just that. There was other things that it did. But there's that pause thing that then launches and then enables it, the PID to be PID 1 for the application. There's a bunch of stuff. Greg, do you have any more insight as more than that?
It all changes soon.
It all changes soon as well. All right. So exactly in the sense, there's a lot of stuff that gets, you know, the infrastructure to get it scheduled, get it on a node, and then all this other stuff of mounting things and grabbing these things and whatever. But the real sequence when it comes down to the application world, okay, from that world, is you can have 0 to n in the containers, which are run in which fashion?
Sequentially.
Sequentially. Do they have interactions with each other? No, because they're run.
If one of them fails, the whole thing starts over.
That's correct.
It's run at the same time. Once one is complete, it's shut down and the next one is
Yeah,
started.
but if there's a failure, it'll try to continue do the loop. So there is a control loop here for that. Okay.
Let's do it in a container. Well, like the sidecar implementation. I don't know if you've looked into that yet.
That doesn't work for any containers though.
But that's how they've implemented it. It's an init container that always gets restarted.
Yes, but these are the traditional ones.
Yeah,
Okay.
Oh.
I'm just trying to get bleeding edge on.
Really? Okay.
What do you typically do or use an init container for? Why do people use them?
Set up a file system.
What was that?
Set up a file system.
Set up a file system. It may be they're copying from somewhere, went out to fault or something, or they went out to here, or they maybe tested the environment to see if it's really going to be okay for later on to start up. There's a lot of different things that happen there. Okay, different from sidecars. We can talk about that a little bit, but probably not. The notion is you have 0 to n init container start, and then you have what are considered the application containers in the pod. Again, this is all in the pod. Okay. Again, here's a diagram of not a diagram. Here's a file, and this was interesting. This is just a pod resource, not a deployment. So this is the most bottom base element of an execution unit in Kubernetes. You can see here that we have an init1 and an init2, and then the app itself. Pretty trivial here. You can imagine what other operations you would use this for. The notion is that if I ran this, you would see this the logs and that stuff. These, and then finally this. What's interesting, trivia, what it's actually trying to do here. Supposed to wait for how long? A second. And this one really should be like forever. Basically, it should be running. It is actually 2 seconds when you look at it and you're saying, okay, deploy that should go ding, 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 ding. No. So just be careful realizing, yeah, it thinks it is, but it's all like when it got loaded up and all that stuff, and it'll only run for 2 seconds. But in real time, it'll actually take a little bit longer than you think. Kind of interesting. Okay. Okay, what are some best practices that some people actually adhere to when they create their images?
Build Shaws.
So I'm willing to say things to make everyone else feel better about themselves.
I need that tonight.
Okay. So I would say when you're building your image on your dependencies, you shrink wrap them rather than taking the latest. You build them frequently and make sure that you update your shrink wrap to be,
Up to date.
up to date. Yeah.
Yep.
Assuming you or the organization has the proper tooling, you'd want to scan those images before using them.
Right.
Um,
Which have their own interesting things of either false positives or fidelity as to how good they are.
Yeah,
It's
it's-
still a good practice.
yeah, it's interesting how, what should I say, you end up having to be an expert in rooting out the false positives.
Small, I think what you're looking for.
Yeah, I'll do them all. And I would add more, and I appreciate what you've added too, because the scanning, the refreshing, and all of those. The key here is most often, and this is opinionated, right? Because
Correct.
many years ago, and I won't get into that story, but it would be fun to talk about this with a colleague of mine who we had many debates on. Why? Why do I care? Well, we can talk about why we care there. Because of load time, copying bytes. Is it always good to have, just pull if it's not present? Not always. That causes some major problems. So there is a notion of keeping it small for the actual performance of getting it up and running. And there's also this notion of keeping what's inside of the image small, not a bunch of junk, just the stuff you need. Early on in the Kubernetes world, actually the Docker world, they thought, Docker, VM, same thing. I have a Ubuntu VM, Docker. No, right? It was, they forgot, no, it's not a virtual machine. It's a packager. It's just a tarball. But the notion here is don't try to do a whole bunch of services, processes in a single container. Best practices, again, but things like supervisor D, other things like that, problematic when it comes down to signals, zombie processes, a bunch of other things.
Everything.
This is where some, again, this is kind of combined to it. This one I think is becoming a best practice. Does it really secure things? Better. Better. And then limit the runtime, the permissions that it has is good. And then if possible, to use a distroless base image. Now, when I say a distroless image, is that Scratch or not?
Ambiguous term is ambiguous.
Is a diskless image, let me rephrase that. Is a distroless image empty? What does it have in it that's okay to keep it small?
Heck,
Solar
CAs in
was-
there,
CAs,
time zones.
time zones,
So like Musel or glibc.
correct?
I mean, I would imagine. I don't know for sure.
I always call it muscle.
Guessing. I was like, I don't put that in there.
Any image you can build that isn't based on an actual distro is called distroless, and you can put whatever you want in there.
That's exactly what it is,
It
because
just doesn't have a legacy like apt update chain or
Right.
RPM chain.
you could put those in, but by itself, there isn't this notion of a package manager. There's not something that actually can grab things from a distro's perspective, the bytes, the libraries, the bits. And Scratch is what? Absolutely nothing. And the problems that you have when you're running into some distributed systems are time zone, CAs for TLS, other stuff, and various other things that are needed. For instance, one of the items best practices was don't run as root. Well, how do you do that? Because so users are gonna Etsy password to groups, some of that stuff. Okay. Here are some interesting ones. This is a very popular one. This one's actually a pretty cool one too. I don't know if you've looked at that one. And then there's another one from Bell South that they're Java people. They're Java people, and so they've done some other things in there. But it's actually a very small base image for Java apps as well. And they have both a muscle or well, that's what I call it. And then glibc, they have both environments. But
So what's the size you're talking about here?
these right here are about 2 meg. So the base image would be 2 meg here. Scratch would be 0. These are about 2 meg. So this is really, in my opinion, of a functional image. Okay. This is the least you can put in it. To make it function. But Scratch really doesn't give you what you really need in a real environment, in my opinion.
It works in just about to the moment you need to do.
Yeah, when you realize that I don't have something,
Library and
and
found
you're kind of like, why doesn't it work? And you go like, oh,
any root certs.
you mean I do need those CA roots? Okay, so even so, on a distro list, just like anything else, Scratch, if I wanted to do some debugging, because that's why we're here, is talking about debugging and specifically how we utilize ephemeral containers. If I try to do an exec into it, which again, what this is doing is execing interactive terminal, the actual image, or I should, yeah. Oh, is that pod name? Yeah. And then the actual SH. One thing, just as a note for everyone, deprecating that you don't have that dash thing. They want the exec to be a little bit more explicit. But anyways, but what you'll get is this message, which is very, very helpful. Kind of. I mean, it does say I can't exec that. But what's interesting is there's a path. I guess maybe there is. I don't know.
Any TTY needs one. Well, any TTY has an environment.
Correct.
And if you want something to execute in that environment on a TTY, you need a path.
That's correct. So that's why the question is, if I had that off of it, would it have that here? I don't know. But the bottom line is this. Distro list, don't have anything in it, can't exec into it. Can't do anything in it. So question is, how do you debug your Kubernetes applications in production if you adhere to best practices? This is a question, not you know, and what?
Debug containers.
So what are some of the things that you do? Don't talk about ephemerals yet. But what do you do to debug in production?
Jump onto one of the nodes.
Okay, that's because he can.
Lots of,
And he's not following best practices at that
Doesn't
point.
There is a large class of problems for which
Okay.
you will not find any of the issues, even with ephemeral debug containers. If you run out of,
I agree with
if
you.
you run out of network connections on your host,
Yes.
doesn't matter what you do.
Now,
to find the
if we
network.
get to it, we'll talk about that ephemeral node possibility that is at least some of it. I mean, you're getting closer, but you're right.
And if it's not happening in your pod, and you
Yes.
have a noisy neighbor taking all your resources,
That's-
you'll only ever find it.
That's
if you
correct.
Start looking at your.
But let's talk about the normal case.
Add log
That's a
statements.
very-
So we build like a debug version of the application. So like a second container image that has extra tooling.
Extra tooling, okay. So, I mean, the traditional one is always this, right? We're all suit people originally. So you just print F it. You just put it out, get a log. And of course, no, I can't do that. I won't say that one. We love logs. We love logs, and those that have been here a long time, you know how much I love logs. But the typical thing is I'm gonna have a problem, don't know what it is, change the code, add some print statements, check the log again. And that's kind of the traditional. Then what was said was maybe create a debug container or something a little bit bigger. Don't worry about the best practices, but roll it out, see if it's okay. Yes, I've got the Heisenberg principle of in that which I inspect, I infect the environment. So then it's gonna be a problematic, but still it's a way. Well, similar type thing in the sense that this is an execing input, right? If I could, if there's a shell there, if I could do something like that. This one here is, well, I'm just gonna build a debugger inside of my image. In this case, I put delve. I'll just have it that it starts up with an attaching to the process. Why not? Have the debugger already there just in case. Very interesting. Who has ever heard of Squash? This came out of the solo.io people.
It's grown in our garden.
And yes, thank you for that answer, because that is correct. I should have been more specific in my question. But I used this several years ago. This is one of the first ones where it did a little thing that provided a remote debugging experience. Not used very often anymore. Telepresence? Who uses telepresence?
Telemetry, you mean?
No, it's not open. Telepresence is a way of faking that you're kind of running locally, but you're in the cluster. It's for networking, kind of like port forwarding using on steroids.
You can only attach to the network and inject yourself in places in the network. So that's but it is a useful tool if you can debug that way.
Yeah, and people do like that and promote that. And it is a choice. I don't even know how to pronounce that, but I think it's called Octecto. That's another one similar to the telepresence, and it does a little bit different nuance, which is interesting, of kind of updating a source in the cluster. It's kind of interesting, but I put that in there because it was interesting. But that's kind of what we do. That's what we've done in the past. And so again, we finally made the review, finally got to the base of what we're trying to say, how we want to do it, why we care, why we're here. I know the pizza's good, but why are we here is, what is the next generation of debugging tools in Kubernetes. And that is, you hear that music? I don't. But that is ephemeral containers. Now, this is not a new thing. It's new for some that aren't looking at the most, newest thing. It was actually introduced in some form, a very primitive form in 1.16. It became beta in 1.23, and in version 1.25 of Kubernetes, it now is stable, meaning turned on by default. Meaning you can use it if you have rights permission to do it. Now, what are ephemeral containers? Go back to that diagram, kind of when we talked about the flow of execution of a pod. Okay, but yes, standard in the containers, standard, this starts running. The reason why this is here is this right here, meaning this side, the left side here, is what pods look like, no matter what. And this gets attached. It's dynamically attaching a container to the pod. That's what an ephemeral container really is. It is attaching dynamically a container to this environment. And there are various means or mechanisms by which it can play in that environment. And we'll discuss some of them. Meaning, can I look at this process? Can I see if we were in that pod diagram where there might be files? Can I see files? Can I do other things? We'll talk about what you can do. But the notion here is an ephemeral container is a dynamically attached container to a pod. Now, there's some limitations or things to remember. As I mentioned there, stable in there. You can't add them by just saying, hey, I'm going to go edit and I'm going to put in the spec and just put a sub resource in the ephemeral container, because when you describe it, and we'll look at it in just a bit, when you describe it, it is in the spec. It is a separate unit within inside of the description of the pod. Remember, if you look at the describe, you'll see the container or containers with their images and all the other things. Well, this is actually another section that is called ephemeral containers. One thing is, so it's only via the API at this point, which means typically the only way you're going to use it is using kubectl debug. That's the new command that you would use. Currently, for various reasons, there's some discussion in the group that you can't delete them. So they're that kind of relative that you invite them to your place and they may never leave.
You should be able to murder the pod anyway.
I'm not going to go with that analogy anywhere. Okay, so, but the thing is that when you attach to them, it's there, and they're not going to be automatically restarted. Okay, so like pod goes down. Oh, where's my ephemeral container? Well, it's not going to be there. Okay. The other thing that's interesting is, well, I'll get to another one, but why we'd use them? I put stuff in them. I put stuff in the ephemeral container that wasn't in the original. That's what they're for. I'm going to add some stuff to the other stuff that wasn't there.
So your container scanner thing is going to go a little crazy on that, I imagine.
Well, yeah, and that's why. Yes.
Okay. All right.
It's definitely something that you should actually.
I'm trying not to be flippant.
But the same reason that you would want a fire alarm
why
to go
people-
off, like,
Yeah. If there was a fire.
they serve purposes, and
Yeah.
it's okay that they go off because that's what they're there for.
Yeah, and I think we kind of had the outer door discussion, pre-discussion, but I think what this brings up, Greg, is this notion of this is not like, hey, anybody on the street, come on, use ephemeral containers. It is very specialized. It's for real issues that are really hard to debug in a production environment because of best practices, good things. And so it really is for getting at those really gnarly type things that you're trying to be good to your best practices, but I need to fix this thing. Right? And so that's what ephemeral containers. And so therefore, yes, scanners will be saying, yes, that's why you pay me. And so that you'll see that. The other thing that's interesting is, again, have to have permission. So it's just not willy-nilly that everybody can do it, which is great because of the capabilities that it does have. And so, again, most like it, best practices, like we talked about, is it would be a least privilege that you give somebody, audit it, that type of a thing. If you're giving it to regular developers. The other thing that's interesting about this, you have to be careful with, okay? Paul, you just said, I can put more stuff in something that's not a lot of stuff. Yeah, I did say that. So what does that mean? Well, you know that pods can have limits to the resources. Actually, there's a great article, and we talked about this, that don't put a limit on your CPU because that'll do some weird things that you don't realize. So don't put limits on CPUs, but you can have limits on memories and all that type of stuff. But what I'm trying to say here is you'll have a good policy to set resource limits because that's helpful to the scheduler to know which, what the packing on nodes, as well as good to not have runaway memory hogs, right? So those are good things to have. But the problem that I'm bringing up here is I didn't know about that thing you just attached to me. And so if I don't have the resources, I try to dynamically add this because how are resources calculated? What was it?
Requests.
Yes, but I mean,
Back at scheduling time, right?
it's at the pod level, but it is the addition of all of the resources or the limits that are associated with each of the containers. So that's why you may think, oh, I've got this on the pod, because that's what you have to add up all the other ones to actually get what the real resource limit is on the pod with all the containers. And that's why here you just have to be careful that I have a really skinny, tiny little, pod that's really good with memory and keeping it really, and then I said, I've got to debug this thing, and all of a sudden it goes, boop, can't load.
Detailed question about that. Does it actually count against your usage?
Yeah, because it's a container, and the calculation would be,
It definitely counts against CPU memory.
Like-
I think,
That's what I'm saying,
because
like-
I think it's all C group, so it gets scheduled in the same C group. And so the enforcement mechanism is already there and is at a higher level than you get injected into.
I think so.
So if you did a balloon pod of memory, it might home kill your whole pod.
Or the container, right?
yeah,
Yeah.
So
Because
why
the-
isn't
well, it'd be
it,
the container. What was this?
why isn't it a sidecar?
Okay, very good question. Why isn't it a sidecar? So if you want to say it's a sidecar, it is, but it's a dynamic sidecar. But it's not a sidecar. So, because in this case, it is a sidecar by definition. You put it in the spec. When I do a restart, that sidecar will continue to be part of that pod.
But I'm just talking
The ephemeral container would not.
architecturally, though, I mean, like.
Architecturally, it is another container inside the pod.
And technically speaking, until 128, sidecars aren't even sidecars, right? You have application containers that all get run after the init. There is no definition of primary versus secondary, other than if you try to attach to logs or a TTY without saying which one, you'll start on the first one. Other than that, containers are containers. There are no sidecars until a more recent version that lets you explicitly say this runs alongside or has a different life cycle management than the main container. And ephemeral containers really are just like, I just need to get a process injected into this
Or a
existing.
co-container.
Yeah, I think the nuances become a little bit skinnier in 128 and above, which will cause changes.
Well, the difference is no matter the method of starting a sidecar with a secondary app container or the new init container sidecar stuff, you have to know it at the time you create the pod.
Correct.
This is saying the pod can have been created however it was created 1 month ago, 1 year ago, yesterday, 1 second ago. I can now dynamically attach another process / container to an app container.
And it's attempting to get back to the workflow that people used to have on servers.
Yeah.
Where you could log into a server, start a shell,
Yeah,
and do some investigation.
that's
That
exactly.
wasn't actually possible inside of the pods. You could do it on the node and then like squeeze your way into the
Yep.
like pods
Yep.
specified things.
What is
Didn't exist in Kubernetes before this.
Wait, the
It exists in Docker. It wasn't, not Kubernetes didn't invent this problem. Like, as soon as we had containers, this whole debug thing became a problem because all those image.
Yeah, but so
especially
even
were still
with
rest-
Docker, I don't think there was a concept of having a different root FS and attaching into a running container.
No, I'm just saying, that's what I'm saying, like Docker didn't have, as soon as we had containers that had small file systems, like this problem existed.
Right. Correct.
CH root jails have this problem.
Yeah, I mean,
That's fair enough. Good point.
the point I want to make here is no guarantees. That's the key. So if you have something that goes like, wait, I need to debug this thing, and you said, Paul, at this wonderful meetup, I can do this using kubectl debug, blah, blah, and it doesn't work. Mileage may vary based on this type of constraint. Okay, so, and the reason why I already talked about this, but again, the resource limits are at each of the container level, but it's added up at the pod, and that's where you may have some problems. Just a note there. Okay. Hey, welcome to the meetup tonight. I'm going to talk about ephemeral containers. So, what are ephemeral containers? As we talked about, you attach things at runtime. Again, it's a dynamic attaching of a container. You have the ability to copy a pod. So it's kind of interesting. There are various options in the kubectl debug command framework that allow you to do an attach. Just put a container in there. Put a container in there. There's also another way of really what you want to do. The second one, I mean, the first one and two are really the same, but the notion is that I can actually copy the pod as it is, meaning I get a clone of the pod. So I can have the original one that it's in production, so I shouldn't touch that one too much, but I can copy it, and this will copy it over and then put in your ephemeral container that has the debugging and the utility stuff to troubleshoot. There's that one. There's also an ability to copy again, pod option, and change its start command. Now, why would that be useful?
Well, wow.
Let's see, crash, loop back off. Huh,
I mean, if you wanted to add like a verbose flag,
could be. Or again, this crash loop back off is like, huh? Why isn't it starting? I can have everything the same except put something there that I know will run and then debug it. Todd.
If you're following all the conversation that we've had in Slack about having the exact same pod that has just like a Go binary or whatever that has many commands that you can run off of that binary, like subcommands or whatever. That's exactly like the flow that I think is envisioned in this.
Yes.
Exactly. Just run like, well, give me the DB console or whatever from this or whatever.
Whatever I need.
Something as simple as like a version flag. So we've had cases where like the image is this, but what hashes the code? And if we could just execute this command on that binary, it could print out to us what the get hash was when it built. And that would be some sort of like copy it, just run the dash whatever, and get the info back. Like you'd have an info dump version of this.
I think the key is, again, like we talked about, is this a general purpose toolkit? Yes, but the use cases are pretty specific. But what's nice is there are tools within the toolkit for those particular use cases that may be very specific.
To be fair, you could do that third one, like without any of the kubectl debug, right? Like anything that has the ability to create
Something.
How are you gonna do that?
Some things.
copy the pod, change the name, change the start point and put it in. Like that's all they're doing.
Oh,
They're
yes.
automating.
Yes, this is saying, I just want whatever's in running right now, because it may be not just the pod, it's an interaction of the environment. There's something weird going on within inside of this cluster. It may not just be that exe or not exe, that binary that would be inside that. So there are other reasons why, yes, you could do that, but there are other things that would cause you
You
to
get
say,
all like the same DNS and stuff as well, so.
yeah. The other is I can actually, very much like the kubectl set image, I can actually copy the pod, change the container images. I can just say, I don't like what you deployed. Here. Again, use case. Maybe there's something that you've added. Maybe you add the debug stuff to that original.
Have a second image that has debug tools.
Yeah.
Like,
And maybe even the source, so that I can do a remote debugging, and stepping through. And that's what you do see some people that actually do that though. In their Docker file, they'll actually compile, their binary, keep the source in there, and then use some mechanisms to then transpose the pathing from a remote debugger.
Not to get too pedantic here, but I'm going to. Those bottom three really have nothing to do with ephemeral containers. They're more about features of the kubectl debug command. Is that right? Because ephemeral containers aren't involved in those bottom three.
It's a first class feature of
Yeah.
ephemeral containers. If you want to copy a pod to a whole nother node and do something with it and not touch the running pod,
So that's not done by kubectl, but by the API.
kubectl debug copy 2
And that
is a first class version of that.
okay, but the API server is the one doing the work.
It recognized that it was a very common pattern, and
Yes.
so they baked it into kubectl debug.
So the distinction I think is valid, meaning is this an ephemeral container? You know, because of that I have this? No. But I think because of ephemeral containers, the way in which you invoke things, the debug now has that option.
Well, that sort of makes sense because you can give somebody kubectl debug without full-on container create.
Correct.
So you can manually do those bottom three right now with access to the API if you have create ability.
Correct.
So the idea would be you probably long-term wouldn't want people to be able to do that. Like you shouldn't have somebody running kubectl run commands on production clusters, but it's okay to have them run kubectl debug commands
Scope of what they
if
can
they're
do.
in a certain group, and that's why it has different RBAC. So you can allow it to take that path instead of using the more
Again,
traditional.
that's the use case why it's important, because of either what I'm trying to do or the permissions that I don't have.
More about, so it's a very declarative system, and you're declaring a much different intent with kubectl debug versus modifying an existing manifest and reapplying it, or just running
Going
it.
through the old,
Or just creating pods willy-nilly. Okay, I see.
because then you may have your whole CI/CD and how you deploy things, why are you doing that? I don't like that going out there, that type of thing. Well, you gave me permission.
A separate RBAC for the two frames?
It's a different verb.
Okay, good. So like there's very different things to be able to do one versus the other.
Now, this one, create, is what we were just discussing. I hope nobody, but few of us, would ever want or need to do this. But this is where you can get some very interesting information that you couldn't have unless you SSH'd into the node itself. And this is allowing you to actually go onto the node with a bunch of stuff like shoot or some of these other sets of toolkits of things that will really enable you to do the weird stuff that SREs may want to do. Right? I don't want to give you SSH, but I can give you this to do that. Okay, it's demo time. Now this is where the scary part of the presentation comes, because it is alive. But just want to give kind of, what am I going to be doing? What are you going to be seeing here? Just in case it doesn't have to work, but it will. We're going to deploy something. I'm going to save off so I don't have to retype the pod name. I'm going to describe to say, hey, this is a normal pod. Then I'm going to port forward and say, oh yes, it works. So hello world, blah, blah, blah. Great, works. And then I'm going to say, oh man, I got something wrong. I got something really wrong with this thing. I need to use ephemeral containers. And this is how I would do it. kubectl, debug, IT, because I want to be able to do something inside of it. I'm going to attach to it, meaning I want to be able to have a connection to it right now. I can specify the name of this ephemeral container. If I don't, it has a lovely naming convention.
So that have to be unique with repeated invocations.
Still runs as a pod.
They are going, you'll get an interesting error. I mean, one says, what? Already exists, I think, or something like that. I'm not sure. And then the image in which you want to, again, you're attaching, you're dynamically putting into that pod. Okay, so we'll do that. Then also, what's interesting about this one, there's a very interesting nuance here. What's the difference between these two? Well, ordering of the pod, I'm sorry. But it's this dash target, and we're going to talk about that a little bit. But this actually gets down to permissions. This is where I get different things. Please, Todd.
Are these all in the default namespace?
Of course.
As a context.
Yeah.
Do you use other ones?
I mean, we can use namespace other than one.
That was a nice way to delete.
Man, all these years. I mean,
I'm just using Cube System for all.
For a demo purpose only, this is a simplistic, yes, this is the default namespace. The difference here, and we'll talk about this is another option, and we'll see what the difference is. But gives us more permissions in the namespace, meaning the Linux namespace, not Kubernetes namespaces, of either file systems, processes, network, those type of things. And we'll look at that. And then we get really complicated a little bit, kind of, is that we'll be able to copy the image. This is the copy command. Similar things here. And then this is going to say, hey, I do want you to share processes when I do, put you into this pod. And then I put this one down here because how many use this NetShoots? Really, this is like the Swiss knife container of networking tools. I mean, TC dump, TCP dump, you name it, it's in there. And so if you have networking problems, this is why you want ephemeral containers. Because this thing right here will then put you into that environment and I can see a lot of things. And the reason I need to do the target is because then it gives me those rights. Now, I'm not going to get into another aspect. There's another option called -s profile. And that is where you can get into more specific. There's actually -- profile equals general, which is a lot of permissions to various namespaces, Linux namespaces again, but they also give you profile equal blah to actually just give you a set or a specific permission set of a namespace.
So one thing, the attached is actually implied with the
Correct.
-i.
Yep.
So it defaults to true if you do -i.
That's correct.
And then the -sh, the NetShoot actually comes with CSH. So like if you really want to debug in style, you can just use CSH.
But for those that have been around, is there any other shell?
Other than SH.
Core shell, K shell.
Oh, yeah.
No, but you're right. Again, this is more to be more explicit, but there are some defaults depending upon which options you use. But thank you, Greg. That does bring up that. Okay. And then this last time, this is how I would debug the node. So in this case, right here, I'm actually trying to, within the pod, get some networking understanding, right? Because again, containers within the pod can have access to the network stack. That's why sidecars are nice for various reasons. But this also, and then the bottom one is again that scenario of I need to get on a node. Networking is problem. I need to do something. Okay. All right. Well, let me stop there. Do you want a demo?
Sure.
You want a demo? Okay, you really want me to suffer? Okay. All right.
I didn't say yes, just so we can still be
No,
friends.
it was implied, but
Nope.
just looking at you.
I want to
and
fight Carson, not you.
Beard was kind of shaking as I said that. No, I'll do it. But I'll ask any questions now because if you want to drop off, fine, but I will do it. Make a fool out of me myself. But any questions before I go to the demo? I'm going to try to demo all that we just talked about as far as the options available and why you would do stuff. Any questions? Any questions online? Anybody online?
Please save me from.
Yeah, I'm here.
No question.
No questions? Okay, perfect. Okay. All right, so
Hi, Jason.
now we're gonna suffer. All right. So first of all, let me go here and make sure that you can see things. How is that getting? Do I need to go to one character or what?
Good, you're fine.
Good.
That's
Is that
good.
good right there? Okay. So. Hopefully I did it right. Correctly. So what we're going to do here is that first part. I'll deploy. Okay, so sorry. like everybody, you have, who types kubectl today? I do sometimes.
Only when making the.
I've got a lot of aliases, so if you start seeing some stuff, you're going, what? I'm sorry, but you'll kind of recognize them.
As long as you don't do the popular alias to K thing.
Okay, so,
Deal.
so going on, thank you. I'm not gonna do it, but, what we're gonna do here, let's see here. I'm going to, let's just cap, some, what the thing is. Okay. Now, first of all, again, simple deployment. Oops, sorry. Looking in here, simple application. Basically, I have a deployment, one replica set. Here's how I do my rolling updates, blah, blah, blah. Everything's all known. Here's my container. It's a sample app container. Meaning that's the name of it. And here's the app. This image that I've created has my app in it, blah, blah, blah. Some interesting things about requests. So here are my requests, my limits. Should have done that, but we'll move on. And then a service to be able to see it. Okay, standard stuff. So go in here and so there we go. So I deployed that thing. So let's go look at it and say, okay, yeah, here's my pod running. Okay. Now I'm going to save my typing abilities. And now I have that stored. So now I can start doing some interesting things. So I have it running. I can do the port forward. We'll see, hello, Utah, Kubernetes, wonderful, great app. But we don't need to do that because we know how to port forward. We know what it means. But right now I have a problem in it. I need to figure out something that's going on. Now, what I would want to know is, okay, first of all, what is it been made? How is this thing created? Okay. So again, when I use this in a production environment, there's a big group of people say Alpine, don't use it anymore. But in this case, I am. So I'm building the app in it. This is kind of this debug version, and then I'm running it. This is a standard. So go app. Okay. All right. So what I need to do next is this. I want to. So I've deployed it and I want it. So now what I want to do is I want to do some of this. I want to attach to it. And I don't know if I really want it now. Okay. I want to do that. I don't know if I want to do that. Now I'm getting confused. No, I may have messed things up just before I. All right, we'll just do it on the fly. What we want to do here is we'll just do a very simple attaching to, again, the sample app is the target, meaning the container I want to attach to. I think I'm going to change this so that it is just a BusyBox image, and that's what we had before. I want to do, in this case, let's see, I don't really have to do yeah, I'll just do the -IT because I don't need to do the attached, it's implied. And then I'll give it the pod. Okay, so before I do that though, I want to describe what's in the definition of that running pod. Okay, so just make sure the before and then the after. Okay, so this is, again, I just deployed this pod.
I think you described the deployment, not the pod.
Huh?
I think you described the deployment, not the pod.
Correct.
Okay.
I did do that. Okay. Okay, so here is the pod. Okay, and we can know that by its resource. Come on, wait for it, wait for it. Wait for it. Did I skip it already? where it says pod, but anyways, this is the pod. You can see containers. There's a simple dash app. That's the only container that's in it. It's running, looks good, blah, blah, blah. And wait a second. I have an ephemeral container. Yeah. Well,
You didn't delete.
I didn't delete it before. All right. Sorry.
Spoilers.
Okay. We'll do it again. Just so that keeps me honest. Okay. Okay. Maybe the pod actually. Okay, so good. 6 seconds. Okay, do the pod thing. All right. So hopefully, if I do that, describe again, it should not have the container in it. It does not. Okay. Thank you. Okay. So I just have it's in production. I deployed it. This is it really is great application, and something went bad. And I don't want to redeploy. I want to be in the production world, but I want to do something. So now I will then do that there because I don't have. Now we'll actually do this command. Okay, and this is where you get that I didn't specify the container name for the ephemeral container. So it'll automatically create this debugger dash blah, blah. So that's the name of the ephemeral container. And now, as you can see at the bottom here, I am now inside the container. Okay. Now if I do things like, there's the app, right? Running. My shell is in there because now I have a ephemeral container. Let's now do the same thing we did before. And you can see the events that occurred that it actually created, successfully pulled the image. This is the ephemeral container here. And now we can see, wait a second. Now I used to just have containers, of which there was just the one. And now I have another subsection, if you will, that has the ephemeral container in it. Okay. Now, what did I say early on as to remember this about ephemeral containers? What was one of the things what will happen if I exit here, right here?
Stays around until the pod's dead.
I restart if I recycle the pod, and
Stays around until the pod is
it
dead.
stays around. So again, that notion of resources, I'm incurring some more stuffs, so I could maybe quicker than I did before. That type of
Are you suggesting that we should clean up our debug environment after we're done?
maybe.
Blasphemy.
I think so. And so that's kind of why that copy, I think philosophically why they did the copy is because one, it's a very simple cleanup, right? You're not affecting the original. And it's something I can just, I know that one. I created that one on the fly, killed that one. As I said, there's some talk. I don't know where they're going to land. There's some talk to be able to do it, but I think it's going to be a little messy.
I think the idea is that once you do this, you can't assume that it's a clean pod anymore. Yeah, so it's basically tainted and they want you
To delete it
Heisenberg
would be
uncertainty.
to clean it out would be to imply that it's clean, which it can't be. It's rather show is tainted forever.
that is all about double things.
All right, so I can see because of how I did this not the attachment, but because I did the target, I have more rights to see things with the namespaces, Linux namespaces, right? So I can see the process that's running. Okay.
If you didn't target it, you would just share the IP address of the pod. That's it.
Yeah.
Yeah, I think you could schedule different namespace. The
You
network
can do that.
namespace,
Oh, one thing.
There's because it does weird things with users, like you run each pod as a specific user, right? Or each container is a specific user, and there's UID mappings and stuff. And so if you target a pod, then you can actually do better access to some of those things. Like it feels more like you exec into it. versus if you don't, they'll just land you as if you were some other container in that fog.
Which could still have value, right?
Yeah.
Specifically network namespace, think of any number of admin things you might have that are listening on 127.0.0.1, right? Like you could suddenly put that in there. It can do that something with that, send it out. Like I'm thinking,
If I'm using this, I almost always want to share PIDs. I almost always want to target a pod because like you're probably trying to look at something really weird inside of it.
Yeah.
And anything that hampers your ability to do that is just going to mean you might have to go out and go back in again.
That's why target is that big thing, whereas the dash dash profile is kind of be a little more specific. But the key here is I'm in there, I can see the process, and I also can, let's see again, let's look at this. I know that my PID is 1. Underneath there's a plus, but I won't worry about that. Okay, so then I want to look at the file system. Right. So I can do that by going into /proc, the PID, the root, which would be the file system. This one, share, Nginx. I know that. Oh. Maybe I can't remember what this is going to be, but you can see that I'm actually inside the file system of the target container. So this is where I could see, oh, wait a second, that's the wrong version of that file that it loaded or whatever. Or it's missing. That's missing in the CA. No wonder it can't get a TLS, blah, blah, blah. So this this target gives me that permission for those type of namespaces, the file system namespace, the process namespace, again, Linux namespaces we're talking about. Okay. Any questions there? All right, so then once I exit this, now what's interesting is if it still is running, if there's a running process, then I could do the attach. I could do an attach to it. In this case, again, if I do the up here, and do a you'll see that one, it's still in there, still taking space, but in this case, almost like an init container in many ways. I've got it terminated. And so in that case, it's almost like an init container in the sense it ran, it did its thing, but it's still there. Okay. The only difference again, if I restarted or crashed, it wouldn't reload the ephemeral container. It would do the container stuff. Okay. I think I'm going to leave it there because I have a bunch of other things that, like the node one, looking at network traffic, how you do a Go, debug a Go process, and all these things are not from me. I'm a Googler, right? Not an engineer, not a Googler, but a Google searcher. And so a lot of this are in the references of where I've grabbed a lot of these things from. So in closing, just as a recap of a couple of things. One is, again, is this a general, everybody, I'm going to see it on I-15 driving, ephemeral containers for you? No, but for this type of group and others, it is a useful tool that given permissions, and I would, again, probably check in, check out type, a limited period, that for certain things, this is a really, really good tool set to have, especially if there are best practices that your companies are doing to minimize things in production on the running containers or running pods.
well, especially if you abstract this away through another tool. If the user is not running the debug commands,
Correct.
but some sort of other
Like
tool is doing it on their behalf, so they can ask, like, give me the whatever debug dump, and it has access to do a very specific thing.
Yeah.
Like, you don't need to give them broad access to this API to get value out of it.
I think it's perfectly fine to do it on development clusters. Production, yeah, probably, but like on the development cluster, like anything you do to prevent your developers from solving their own problems just makes it your problem.
That's true.
So this is the tool that they should be using so that they can keep having small containers, and like you still don't need a fat dev container. If you can just spin this up right next to it and they have the full commands to do that in their namespace. And it's more on production that you're like, you don't want a tainted prod process that like, oh yeah, Jimmy went in there and did some stuff and like used a bunch of memory and now it's acting weird.
And it's still there.
Yeah, so.
Are you enabling developers though to develop bad habits, right? By giving broad access to
No.
dev? Because I mean, are
Best
they gonna get,
practice, like-
are they get lazy? Like, I'm not gonna add any instrumentation to my code or anything.
No,
I'm gonna go back to the VM old school.
I think,
Exec in to
yeah,
do anything,
so
right?
again, not execing.
But
I know, semantically. No, I think what you're bringing up is valid, but again, what we're trying to build is professional engineers.
yeah, so I mean, I think
The intent is you are going to do those best practices. You are going to make sure that you're doing things. But as a good engineer, you're going to say, I know I'm going to be limited in prod. I know there are going to be some issues in prod that I can't debug, but what I can debug in dev, like Greg's saying, is give them all that they can so that they're not saying, I don't know, printf, and I need all these logs and I need millions of dollars to spend on logs this year. You know?
And especially on like networking calls, like I'll take Wireshark over whatever you try to build into your app any day.
Exactly.
So, like, don't reinvent the wheel on that. Like, hopefully, yes, you can observe your app to that extent, but the edge cases are there for the things that, like, I even trying to say, like, oh, you can script away a dump. By the time you hit certain problems, like, you need to just get in there and actually inspect what's going on.
We'll talk about more of in a production case. Like you can still use this feature in cases where you can't give it.
And even in production, that's the idea is being like you get into a single pod, you could actually copy it. So like if it's so harmful that you literally can't touch production, you can try copying it and hope that it reproduces there. Oftentimes you're talking about like memory resident state issues that you just have to get inside of a pod and then do some introspection, figure stuff out, and then delete the pod and like go back to the known good state. And being able to use all the tools that have been developed over like decades, instead of saying, "Oh, why don't you put traces in your app?" It's like I did, still didn't help. Like trying to use traces to troubleshoot very obscure like sequence timing issues, or you ran out of sockets. Well, trace isn't going to help you when the networking falls flat on its face. And that's the kind of thing that if you jumped in here and you started being like, "Oh, I can't establish any connections to anything, and it looks like the whole networking is screwed up," and you could use T-Shark or other tools to be able to get you that answer. Previously, your only hope was jumping on a node and then like wiggling your way into the CNI's like network namespace, and this just gets you like right in there. It does kind of exactly the thing you need to do using the tool set you're used to, which is the best part about it.
Yeah, so again, I think, Josh, the key here is that differential. This is not about observability metrics. No, I think you bring up a good point is that, no, those are those other best practices. You're not eliminating them. You got to observe, you got to measure, you got to be able to see those things. And maybe there are other tools that get kind of like this, like those expensive tools I won't name, that you can look at database queries or, whatever, they can get down into that interesting world. This really is that tool set on which one would use in very specific use cases. But I think what we were talking here was it is good to give them the option to do that in dev.
Yeah.
And then limit it if necessary in a prod environment. Because again, I can see myself using this to do remote debugging.
Yeah,
And that to me is very amazing because I don't have to do all these printfs. I don't have to, yes, I'm injecting stuff into the environment, so I have the Heisenberg stuff, but still it's less because now it really is that pod running. It is that thing running. I'm just adding something that now inspects it.
From putting on manager hat, if you don't want them to do this often, like you want them to have this option, but you don't want to like use it as a crutch, audit it and then be like, you use this 3 times today and I don't have any postmortems that you filled out.
Yeah.
If you don't want to fill out a postmortem, don't do it.
In production,
Yeah.
but in dev, I think I would,
Oh, and Deb, just do
Yes.
whatever.
Just delete those
you know.
You're mad.
To do debug.
Admin, that-
Yeah. What was that? Yes.
Get an admin with your guy.
I would, well, I won't go there. Yes, I love that too. All right, so again, purposeful tools for good use cases. I think I only see in the future more enhancements, more little changes, because a lot of these things over the period of time that when I kind of look at it, you can see, so, hey, can you do this? I'd really, you know, and they kind of add something or they kind of anticipate something else. So again, hopefully this has been interesting. I think there are probably wise to do a tool set on top of it or something, you know, that wraps it a little bit and auditing and that stuff. But again, I find that this is a really cool thing. Again, stable 125. I know not everyone's running 1.25, but still, it's a good tool to think about. So I'll leave it there. That's it.